First things I want to say thank you to EclipseCon and to Eclipse Group. That is fantastic preparation of these events. And it's a pleasure for me to be here like a keynote and present our robots and also other robots that you will see in our slides. When I just choose the title, I just think that we did something similar in 2008 when we present our second biped robot. And we did a very beautiful video that I want to show with you in order to show you the path of robotics since 2008.
The Czech writer Karel Čapek had a cold and a touch of fever on a winter's day in 1920. The last thing he needed was to find out that his tea had run out. Wishing there was someone there to refill it, an idea came to him. He typed a word on his typewriter. Robot. Yes, he would write a fictional story about humanoid robots, machines designed with the intention of helping people. The invention of the word robot was the starting point for the development of humanoid robots like me, even if those first results of human fantasy were creations that today might appear strange or funny. In the early 20th century, for example, a mechanical trumpeter was created. Some years later, Electro became one of the first humanoid robots. He wasn't very smart, but he was able to smoke a cigarette. Well, unlike Electro, I don't smoke. The Rancho arm from 1963 was the first computer-controlled artificial robotic arm and was designed as a tool for handicapped people. I can also help people in need. In 1979, RB5X robot was equipped with software that enabled it to learn about its environment and to navigate independently. I can find my way around in any room. In 1999, Aivo was created, an intelligent and really cute dog robot. Sit down. Asimo was presented in 2002. He is a much respected member of our robotic family. Did you know that Asimo has some incredible features and is even a fantastic dancer? Chess-playing robots and computers are becoming more and more advanced. The outstanding technology of Hydra, another creation by PAL Technology, even leaves other robots behind.
Check.
I must get more practice at this game. Sorry, I presented you some members of our robotic family, but didn't yet introduce myself. My name is Reem B, PAL Technology's latest humanoid robot. I am a part of the evolution and development of humanoid robotics. I was made to help people, and I possess the skills to lighten people's everyday life. I can walk dynamically, recognize and grasp objects, lift weights, and I'm able to orientate myself inside any building. I can speak to people, and I can accept voice commands. I recognize faces and recall appointments as well. Of course, I can bring you a cup of tea too. Karel Čapek would have liked me, I guess. Want to get to know me better? All right, I'm coming.
This was in 2008. So the video, it was, for me, yes, has a special meaning because we did all this stuff in 2008, up to 2008. But let me show you a little bit our evolution in PAL Robotics, what we did at the beginning. You will see also a lot of video about these robots in the presentation, so don't care. Don't make the question now. You will have the possibility to see these robots moving. And we started in 2004 with the first project with a chess player, Rim. Then we did the Rim B that we presented in 2008 in Rim Island. This is a big island just in front of Abu Dhabi City in the UAE, United Arab Emirates. And since then, we just made other wheeled robot, always focused on service robotics. This is exactly what we want to make the difference. We don't want to enter in industrial robots, but we want to provide services. So since the beginning, we just focus our mission in helping people and interact with people. And since then we create a different platform, and I will present you all these platforms during this presentation. These are some of the robots that we already did. And so yes, a lot of collaboration all around the world. This is an old image, so we increase a lot all this collaboration project and also clients that we have. We have support from big infrastructure in order to give support to all our robots all around the world. Imagine that we have robots in Australia, in the US, and not in Canada, not yet, but we will try to make it soon. And so this is important in order to don't travel all the time in order to fix any kind of problem. So from software point of view, solved, and up to now we didn't travel too much for hardware problems. About expertise that we did everything from design point of view. So not only mechanics, electronics, but we are very strong in control. That is something that is very useful in order also to make the proper interaction, and also some kind of software and top-level application with human-machine interaction. But now,
deep in the heart of the city of Barcelona,
see this video.
One of the most beautiful and modern cities in the world. There's a group of passionate engineers devoted to a single goal: to make our lives easier. We are PAL Robotics. Nowadays, technology is helping us with our daily life. But we think it can still be improved in so many ways. That's why we want to go one step forward by using robotics. We firmly believe that robots can assist humans in ways we can't even imagine. Robotics has an inconceivable potential, and we are convinced that it will improve our lives like we've never dreamt before. Imagine a world where you can transform repetitive and annoying tasks to something practical, fast, and even enjoyable or engaging. This is the future we want to build. But there's still a long way to get there. This is just the first step. In PAL Robotics, we have spent more than a decade focusing on humanoid robotics research. Since 2004, when we launched our first humanoid service robot, our products have been evolving continuously. Our service robots are being shipped worldwide and are used every day. Over the years, we've been accumulating a lot of experience in many fields, and that has pushed us to develop new robots for solving specific needs, like inventory taking for retailers, ambient assisted living, or like industry demand. You are invited to come with us to this new feature we are building together. We are PAL Robotics.
Marketing video. But there are not only PAL Robotics in the world, and there are a lot of companies that are more known and had more success and are very good also making robotics, like for example Honda. I will present you now in the next slides some of the very well-known companies that are doing very great job, and we admire every day, because for example this robot, the Asimo robot, that probably you already have seen in some exhibition, because they have also a strong department in Belgium in order to make events, is something that make incredible things. We have different meaning. Also, in order to design the robots is completely different when you have to design a robot that has to be able to run in order, for example, of weight, and a robot that has to provide services, carry weight. Also, so the design is completely different. So for example, this one is something that is still something unstable for biped robots because of the whole body control. But I will explain to you a little bit more in the next slide. Here, I just want to show you how many prototypes they did since the 60s in order to arrive to this very good robot that he has. And another thing that Honda is doing is not only about biped, because you know it's very well known about automotive, but it's also about mobility. So they have a lot of other products like this, and probably this one you have already seen in the streets, probably in Japan, that make the difference and try to make a step forward in order of mobility of people. So Honda is just an example. I think it's one of the best company that focus on robotics, but there are other companies. And for example, we have one French company that now is Japanese because it was purchased some years ago from SoftBank Group, that made also beautiful design about beautiful robots. Like you can see here, probably you already know the Now is very well-known robots. It's also the platform standard in RoboCup in order to make competition with robots. Then they did the Romeo project, that is a biped that is comparable with our robots, with different features. And now one of the important things that they are doing is just pushing a lot with the new robot that is Pepper, that you can see here, that is a robot that they want to introduce in every house in order to help in our domestic environment. So this is their idea, their focus, and they are doing quite well in order to open the market for everybody. So it's not just a competitor, it's also in some way a friend because it's opening robotics for everybody. Okay, then there's also marketing, and they are very good in marketing, so they did beautiful things with the video. So another company that it works a lot in robotics is Toyota. Probably you know that in the last years they are working in autonomous navigation with cars. They are trying to make assistive conduction with cars. But they also had a different project on robotics. So here you can see a biped robot that is also running. In some way they are competing with Honda in order to have also their own robots, because Honda did it, so we have to do. And so they did their own robots, biped robots, that is able to run and everything. Nowadays, they focus also on service, and they have this platform that is a standard platform for the RoboCup at home competition. And it's a robot that has only 4 degrees of freedom of the arm, and try to make services like Pepper, but in a very, let me say, the straightforward way. So they want to do things with this, not only emotion or interaction with the robot. So they want to manipulate things, grasp object, and also make real tasks, like you will see that this robot is able to do. Another very well-known company that is in US, that is also purchased by SoftBank, the Japanese firm, is Boston Dynamics. And here just I put some of the development that they did, and the video that they did is quite impressive for everybody. And another thing that they produced in the last year is the mini spot platform that they want to introduce in every house. But let's see if it works and how it will be in the next future. But what is important to understand is, from control point of view and also for robotics, this is something that is very difficult. It's not easy at all. And there's a lot of hours, not only from hardware point of view, but there's a lot of control and software and real-time control. That is something that is very important to understand. So this video is very famous also for another things, that from ethical reason, I don't know if you heard at the moment, that is stop abuse against robots, because in this video they just push the boxes, try to make things with the robot. This is exactly the part where they just try to simulate something that could happen for real. When, for example, we have to take a box and in some way we have, I don't know, not too much grip or everything, and this fall down, could happen. But from other point of view, for people that probably are not expert in robotics, could make sense. Why you are making this abuse to the robot? What's up? It's strange. So create a debate in robotics community from ethical point of view that is quite strange, but yeah, understandable. Also this one, yeah. So from roboticist is just the way to show that the robot is robust enough in order to fall down and then just stand up without any major failure. But it's a kind of abuse, huh? I agree. So another company that is doing very well is from Japanese company Kawada, that made the HRP project. Here you can see the different models. So they started with these robots, and one of these robots is also here in Toulouse, and this one, the HRP2, is in the last laboratory, and probably you have seen, because it's also very famous, did a lot of experiments. They use it since more than 10 years, and this is very good robot. And from Kawada, another things that they are doing is using the next stage robot, that is this one, this platform, that is this time is with sometimes with wheels, and this time is fixed blocks on the side, in order to be in a position in a production line in order to make manipulation tasks. And yeah, there are very beautiful robots, and it's something that has to be mentioned. But
in PAL Robotics, we always believe that humanoid biped robots are meant
this
to be
video
part of our
explains
life.
why we are
They
doing
will help
bipeds.
us in our daily tasks to make our life better. That's why, back in 2004, we decided to build our first humanoid biped robot, Ream A. It was able to walk and play chess by himself, but we wanted more.
With this video, you can see a
we
fireplace
launched
over
our
there.
second generation of biped robots, Ream B. With a payload of 12 kilograms with both arms, it became the strongest electrical robot in the world. During the following years, we kept working and researching, improving and implementing new features in our robot. 5 years later, in 2013, we were ready to launch the third generation of our bike, Ream C. And now, in 2017, we are proud to present a collaborative robot for industry environment. Made for cooperating with workers in non-automated heavy assembly chains, we have built a completely different and unique robot, making a huge emphasis in being modular. Meet Talos, the most advanced robot from PAL Robotics.
So when I said that in the last they have the HRP2, they just purchased last year the Talos. So the first unit of our robots is called Piran, and is also in the last. And you will see also some video inside the last. But now, just make a step behind and see about all the robots that you have seen, a lot of video with PAL Robotics, whatever was it. So the motivation is quite clear. We want to use biped robot. We believe in biped robots for very easy things. One is that we think that with service robotics, we have to use the same tools we create for humans. So why we create the chairs in this way and not another way? Why we have these stairs? It's just because it has to be useful for us. As for this reason, we think that the robots and robotics has to be clever enough in order to use the same tools. And this is not happen, for example, with car, because we modify all the environment in order to have streets, traffic lights, and everything, in order to have the mobility faster. But we don't think that it happens with service robotics. So this is a different challenge we try to solve, and for this reason, all this stuff that you can see. Here, for example, it was very crazy because this was in 2006 in San Francisco. So what we did is try to put the real robot in a real environment with real people. This is the important things that is still a big gap between research and robotics. Here there's a comparison between the different robots, and also another important thing is about the autonomy of the robots.
Meet
and now the REAM.
Your humanoid service robot at the Abu Dhabi National Exhibition Center. REAM can map and navigate any environment.
Please follow me.
Using its front and back cameras, it can guide you to your destination and even remember your name. REAM can share information with the user about a variety of different topics.
Have you been to Ferrari World?
Make video calls using REAM's high-speed video conferencing technology.
Starting video chat.
REAM can be programmed with various customized applications to assist users in malls, hospitals, hotels, airports, and museums. The future of humanoid service robotics has been developed by PAL and is your guide at ATNIC.
So, in 2008, after the launching of the REAM-B, we just started producing the REAM. That is a way that we just try to open the market that now a lot of companies trying to open it, but imagine that this robot with a touch screen, we start creating in 2009. So we are thinking about 10 years ago, more or less. And the idea is to have a stable robot that could provide services with a long autonomy, the possibility to have not swap batteries in order to use it 24/7, and with different application and different capability. And what we did is a lot of events with this robot, because we overkilled with robotics the capability of the robots. And for this reason, the robot now is very expensive, but it's very stable and very robust, and still have a market. And now we are renting, for example, for events and everything. And I don't know if you read the news, but Dubai police just purchased some of these robots in order to have a RoboCab that provides services in Dubai shopping malls. But this project started in 2009, not yesterday. And yes, about events, we just had the robot in very, very different scenario with different culture, and this was something that is very important, because we learned a lot with all these events, with all the different culture, and about aesthetics, for example. Let me say that the aesthetic of this robot is completely different from this one, and the market depends on the culture of the people. So a robot that could be beautiful for Indians, Chinese, Abu Dhabi, and the US is very difficult. It's not easy task. And we learn a lot of things with all the events where we use the robot and all the application, and we also seen a lot of strange behavior of humans with robots. We have a strong experience on that. Anyway, all these robots now, the prototypes that we did, that you have seen in this video, are in the Science Museum. So there's open now one fair there that is called Robots, and they also use our robots for the image of the exhibition, and you can go there and visit up to 3 September, and then I will be in Manchester, Tokyo, Singapore, wherever for 5 years. The robot will travel all around the world in the museum. So don't lose the opportunity to see them over there. Now pass to something that we are still using, still selling, and still supporting a lot of partners that are using that, like the REAM-C. The REAM-C born in at the end of 2012, let me say. We had a big partner, a big university in Russia, in Moscow, that just contacted us because they had a big problem. The problem that they had is that they had a beautiful mathematician, beautiful engineers, beautiful roboticists that loves marketing. And so go to US, go to Europe, go to Tokyo in order to use this kind of platform. And so they really need one appealing platform in order to use it, and with open source in order to change everything and give this to their brain in order to increase their robotics added value. And from this needs, it born the RIMC. So RIMC is 100% on open source. It's ROS-based. You can use simulator also online. Has a long autonomy. Yes, there's a lot of beautiful skills that you can see in this video. It's perfect, whatever. But the most important things is about the software point of view and the robustness of the platform. So imagine that we did it in very, very limited time because we had just 1 year. So we started the project in January and we finish in October. And you will see now the images. Yes, and if you want to purchase, please do it. But the images that you can see is here. This from the concept that they arrived and said, okay, we want to do that. And imagine we had a very big competition with Japanese robots that also want to have this project. And we just shipped the robot in October. And it was a very big challenge for us. And now we are proud to have the platform. We already sold all around the world. There's in Mexico, in Germany, yeah, there are different platforms around the world. And they are using also the different middleware. And it's a very beautiful platform. And we also use for different events. So here you can see some events where sometimes we are doing our marketing. Some other times is clients that ask us. For example, recently we did the big event of Deloitte that it was in Barcelona with the RIMC, that it was in a theater. So it was, imagine a big theater in Barcelona with the robot in the park, just moving, say hello to the public, just then go down. Yes, we are doing a lot of good stuff. And also you can see different events. For example, here is the dynamic walking conferences. Here is the humanoids. For sure, we will go also to humanoids this year. That is in Birmingham, and the platform is very stable and very robust. And now, just let me spend some words about the biped robots. That the last one, that is the Talos, that is completely different from the RIMC. So the hardware behind changed a lot, because all the robot up to the Talos, it was based on the CAN, so Control Area Network bus, with limited bandwidth, limited frequency. And with this robot, we just change and pass to EtherCAT. And so we could have a very fast control loop, up to 5 kilohertz, and is fully torque control. So it means that for real, we have the torque control in each joint, and so you can make the real force control of all the robot. We are still working on it. It's very tough, and we are collaborating with Toulouse just for this. And it's very, very strong about the payload. It's up to 6 kilograms in this position. About events, we have not so many videos because it's just new. But here you can see, for example, in the presentation that we did in February in the LAS, here is in the LAS. We have the robot that is just stretching the left arm with 6 kilograms in this position. And also in the presentation, it was walking and other stuff. And yeah, and the idea is that the LAS has a joint lab with Airbus, and they want to build industrial application with a biped robot in order to use it in some particular production line where it could be dangerous for humans. Now, make another step and forget the biped for a moment and put our eyes on collaborative robots, what they call cobot. There are a lot of robots. So you can see here, big companies. And in the world, there are now something strange that it happens, that is the big usual company, industrial company, that you can see here, and here, you know, these big companies that are very, very, very common in industrial environments. They want to enter in this sector of collaborative robot. And from the other side, companies like us that are from scratch on service robotics also starting entering on that, because it's our natural path in order to have interaction and collaboration with humans. And so this is something that we will see who will win and with which application. One of the applications that at the moment is not with arms, is just with the autonomous navigation, is something that is going very well in PAL Robotics, that is the autonomous 3D inventory system. The idea is a robot that wakes up during the night in the shop, just make a path autonomously, and manage the out of the stock of your shop. And at the same time, also see the misplacement, and so it can detect if something is in the wrong place. And is without any modification at your environment, and you can connect all the time to the robots. This is something that is now revolutioning all the system on the shop and the retail, but retail, imagine, is very fixed and stable market, so the change takes time, but it's doing very well. And we just had a lot of good part, and here you can see also the time reduction. That is, imagine that to have this big surface, the people that has to make inventory and go with the handle in order to make this took at least 5 hours, and with the robot you can do it in 1 hour. And the accuracy, there's completely different. So it's something that is going very well, and we have our solution could be integrated, and also another important thing is you can use this real-time data in the big data in order to have a better forecast and prevision about your business. This is very important for this. And now, just see the robot that we have here, that it was quite up to now. I will try to move it a little bit, if allow me to do it. So behind me in the screen, there's I can go to maximum velocity in order to go down to the screen, but not. And I will try that he present him itself, and this I can control with my mobile phone with a VPN. So if you can try, you can connect to the robot. Okay, if you are very smart, probably yes, but yeah. So
there are people around. There are people around. Well, I will present myself. But first, let me prepare before start. I need to stretch a bit. It will take just a few seconds. Okay, I am ready. Hello, my name is Tiago, the robot that adapts to your research needs, not the other way around. I have a differential drive base. With the laser rangefinder, I can map the environment and navigate autonomously. My torso has a prismatic joint. This allows me to adapt my height easily and increase my work's pace. By lowering my torso and using my 7 degrees of freedom arm, I can reach objects on the floor. You see, nothing escapes to me. On the other hand, I can stretch my torso. That way I can easily reach tables and shelves. With such a workspace, I can be very helpful at home and in industry, don't you think? I have a pan tilt head with an RGB camera that helps me navigating safely, recognizing objects, people, etc. I can also interact using my speaker that you are hearing now and my stereo microphones here. Have you seen my laptop tray? Let me show it to you. It is specially designed so that you can place your laptop or any other device. Furthermore, my expansion panel has USB and Ethernet ports and power supply to connect whatever you may need to expand my capabilities. Oh, I was forgetting my end effector. Right now I have got mounted a parallel gripper. Nevertheless, I can use upper end effectors like the Hay 5 hand, or you can integrate your own end effector. And this is only a glimpse of what I am capable of. If you have any question, please ask to my colleagues at PAL.
We have to make this presentation faster because sometimes it's boring, you know? But you have seen that the robot have 7 degrees of freedom, the arm, so there are several things that could be done with robot. And yeah, anyway, he will be here in the stand, so I will show you also different things during today and tomorrow. And if you have any question or whatever, just ask. And I have different demo that I can show you with robot. But yeah, let's say that about the modularity and configuration of the robot. For sure, the robot, it means Tiago is acronyms to take it and go. So this is the idea. The robot is able to is useful for 3 different things, that is perception, manipulation, and navigation. This is the things that we are offering. So for this reason, the robot could be configured in different ways. So you could have just a mobile base, or the mobile base with torso and the perception stuff, and different kind of arm, and then the effector in order to make different kind of manipulation or perception. The idea is also that you can add your own sensors here directly to the robot, and you have different points where you can connect the things. You can take your laptop and use it directly, the robot with your laptop here, connecting to the central computer of the robots. Here is the possibility of the combination. This is, for example, the 5-finger hand that you have seen in the video, probably. You can use different laser range sensor. You could have or not the force torque sensor in the wrist in order to make a precise manipulation, and the different end effector. About mobile base, yeah, here behind, I don't know if you can see it, but yeah, behind you have these kind of things. Yeah, this version, for example, is without the dock station, but we have also the robot the possibility to have with the dock station. Usually there's here in the front one little plug where the robot is just can plug in and go autonomously to the dock station, like the vacuum cleaner that probably you have at home. And the robot is also able to do this. And here you have the display, the possibility to block it with key. That is important also for security and emergency stop. And yeah, the important thing is the autonomous navigation that is based on ROS, that you can use our stack or you can use your own if you are expert on that. About the ARM, we are using very good components like Harmony Drive from Germany, and we have our own solution that we call the module, that for example is M90, that is the motor, the reductor, and the electronics of control embedded in the same system. And here you can see a hole that is for the cabling, because when you have one joint that is moving, the cabling is the most important part, because it could be, after a lot of rotation, could be broken. And this is the problem that a lot of robots at the moment has. And our solution is just to have the cabling that just don't suffer because it's in the middle. And so you could have a more robust solution with that. The expansion panel that you can see over here, yeah, it's good that I can move with the joystick. There's the expansion panel that you can see. You can have a Giga Ethernet port, USB 3.0. You can connect directly to the CAN, the control area network, or have the power supply in order to put a new camera or whatever you need. and for sure the laptop tray that is here. The torque of waste space you have seen the presentation. So one thing that has to be mentioned is that the robot has the 180 degree in this position. That is important in order for the workspace. And in the head, yeah, you can have different sensors. About the navigation, this is something that we have. We have different also applications, like we call the map editor, in order to also fix some zone. This is a simple application where you can fix it. For example, you can say, okay, the robot has not to enter in this parallelogram, never. And so this is the forbidden area that you can just put in the map of the robot. And about the manipulation, we have also a graphical user interface that is very easy, where I can move joint by joint of the robot. I could have access for everything of the robot. And yeah, also with the joystick, I can move it. I can send to the robot different sentences that I can say. And yeah, and with the robot, sometimes we play a lot, like you can see in this video. And we try to make a domestic application and different things, like cleaning a whiteboard or make a coffee or things like that. And this is very exciting. Yes, the remote interface I just said you can, yes, also with your mobile phone, see what the robot is seeing at any moment. You could have, in the simulation, access to all the sensors, and also for research is very, very interesting part of the robot. And this is one scenario that we love to have in the future. It's not yet there, but we are working also with some big company in order to make it, that is the multi-robot, and so the robots that could collaborate each other in order to have the same task and make different tasks at the same time. And this is something that we really love to have in the near future. For this reason, what we are also doing is certification. That is not only the simple CE that is mandatory in UE, in Europe, but also the ISO, and this is the most important one, that is the service robotic ISO that we are trying now to pass with a big company that is helping us in this process. But it's very tough and long process in order to have it. Also, if you already have everything that is good, it's a very long process. From software point of view, we are based on Linux. We are using Oracos, that is a middleware that is for real-time, hard real-time task that could be based in Xenomai or not. For example, now we are using the RT Prompt, but in the past we used a lot Xenomai. And ROS, that is Robotic Operating System, that is the de facto standard middleware in robotics. And we are the official maintainer of ROS Control, that is one abstraction layer that provide all the community to use not only the PR2 that it was from Willow Garage, that is the company that created this standard, but all the other robots, and then for sure move it and other software that you can plug in the robot. Yes, this is just the logo of the different software that we use. And now I really love these slides because give a little idea about how could be complicated one software for robots. So robotics is not just moving one motor and that's it, but have a lot of relationship with a lot of different, and this is just the package release for the navigation. And here we can have an example. This is the PMP2 navigation and all the different application that it needs. Now I think that we don't have too much time, so I just want to show you with some images, some video that you have seen, that I love video, so I love to show you video, about challenges. What is still missing and what we have to improve or make it better in order to have a better robot and providing better services. One of the big challenges for sure is navigation. We have our solution, but it's not perfect. Like all the other solutions that are in the market now, we have to improve it. For example, here you can see we made it real test with a real robot. Here it was more than 2,000 square meters of surface. Imagine a map that have this dimension. And we did it, and it works quite well using, for example, an algorithm of divide and conquer, or just a simple go from one point to the another one, but in a real conferences, like would be, for example, here in the coffee break. This is very challenging for a robot. He has just the sensor that in order to understand what happens in the world. Then another important point is the interaction. Interaction could be very difficult. For example, here is the simple things like following the ball. This was done with the rim, with Thiago. Here there's the possibility to have a kind of avatar of the robot, so you can control remotely the robot just using the natural language, so your body. And here is the learning by application. You can teach to the robot what he has to do. And so here my colleague in a real conferences in UAE was just teaching a movement, and then the robot is able to repeat this movement all the time. So interaction is a very big challenge. And perception, about perception, yes, here probably later also understand, I will show you also with a Ruko marker the possibility that the robot could follow the things and put the effector where the marker is. Here is, for example, to follow the right face and not only the biggest one. And here is a sensor fusion where you use all the sensor of the robot in order to follow the right person. And here my colleague is just using the Oculus Rift that probably you know it. It's very well known for video games in order to teleoperate remotely the robot. And you could be there and see exactly what the robot is seeing. Other things is, okay, about simulation. Simulation is very important also for us because it allows us to don't have one robot like this for each programmer, but using the simulation is, from one side, is a sales argument because our clients can download the simulation is for free on the website and use the robot in simulation with Gazebo for free and see if the robot could be okay for their application or not. And at the same time, for us, to developing the new application is very important. So what we guarantee is that the robot, the model, the dynamic model that we put online is 100% the real robot that we are in selling or we are in our facility. About manipulation challenges. Okay, I just skip some slides. I don't know why they don't start. Okay, manipulation challenges also is very strange. About, for example, this example, this was done several years ago. But one of the interesting things was for the robot, it's not exactly like humans, but when you have to grab something with this kind of hand that we had, the most stable solution it was not to grasp the object in this way, but it was to grasp the object in this way. That is completely not natural at all, but it's the most stable way because yes, we could have more stability in order to grasp the robot. And so these things are very good for the robot because it's more stable, but it's not natural, so have a big impact on the interaction. And so if you see a robot that is making strange movement, you'll be scared. You will be scared. Also, if you love robot, you will be scared. It is something that we already detect a lot of times, and it's very important in order to make the robot as fluid as possible and making not strange things. And for sure, biped, yes, this is our dream, and we are working on it. And there are a lot of things that we have to work. And this, from one side, the end effector, the other side is the carrying weight. Like here, for example, you can see here that is not stable weight because yes, the water can go from one side to the other. That is the more complicated for the robot to balance it. And here also pushing the robot, sitting in the chair, using our tools. Come on. And finally, the whole body control. That is now something that we are doing online with the robot. And here you can see also with the Thiago. I can show you later a demonstration with the body control. And here, for example, the robot has to put the hand where you can see this two red point and at the same time see the one position with the other. So in this way you can create this very strange position, always taking into account the self-collisions and also the possibility of fall of the robots. The robot has to be stable all the time. About partnership, yes, we are quite active since a few years to European project and also international collaboration. We have already active project, and already Gail mentioned Roboto. And I want just to show you this slide about the Roboto project, because we have also some important points. We have two brokerage events. One will be 11, the 5th of July, and another one will be in August, the 24th of August in Frankfurt, in order to create the community. The idea is it's a cascade funding project where we ask people in the community to create projects that will be funded by this project. So if you have a great idea, you want to use robotics, or you have this idea, you can just apply and be funded your project. And yeah, I hope that someone of you could be interested on that. There's the website where you will have all the information, or if not, you can ask to Gael or to me in order to have more information about this. Or just go to the brokerage event in order to understand a little bit better the open call that will be open very soon. So I think that I took a lot of time, so it's the moment to finish the presentation. I want to just leave you with few messages. One of the big messages is that service robotics could not be done from only one company. Even Google, SoftBank, or whatever big company that is trying to acquire whatever can do nothing without community and without the effort of a lot of people like you. So please help us in order to have this dream. Then the aesthetic is important, for example, for the human-robot interaction, using also standards. And my favorite sentence is the last one. That is, I think, something that I've seen today a lot, that is the passion and motivation of people that don't care about money, don't care about things, but just have passion and motivation for something, to do something and to realize their dream. So please continue doing what you are doing and love robotics. Thank you. And now it's moment for questions.
Thank you, Francesco. So yes, maybe just one more word on the Roboto topic. If you can go back 2 slides. Yeah, so the idea, one of the main points of Roboto is to use Eclipse tools, Eclipse tooling for model-driven development of robots. So, and again, there will be 2 open calls. So I'm sorry, but that's only for European companies. So, and but the 2 open calls, applicants can get up to 250,000 euros for the project. So that's something that is certainly worth investigating. Any question to Francesco?
I hope that it was not so boring. Anyway, I will be there. I will be there in the stand.
Yes. Francesco will be at the exhibition. Yeah, I think that it's very interesting to get to see that there are these movements, and so from SoftBanks. And but I asked you the question. So, what do you think about those acquisitions? Why do they do that?
The why, I don't know. For sure, is a kind of control that I can understand that they want to have about robotics. So this is for sure. And from other side is when, for example, Google purchased the 8 big company in US, and one, it was Japanese, the Shaft company. It was a big movement from a media point of view, so marketing point of view. And I think that also the marketing now is one of the big driven at the moment.
Yeah.
Sorry.
I can't hear you, sorry. I can give you.
There has been a lot of advancement in machine learning, notably deep learning, with the technologies like GPUs. And do you think that deep learning will play a big role in the future development of these robotic systems?
For sure, yes. Deep learning at the moment is very good for a lot of tasks. What I don't believe that it was one of the presentation that I attended in the ERF in Edinburgh. It was about deep learning will substitute everyone, also robotics. I don't believe that, but it's very useful. And they have also some constraints, and there are a lot of things that doesn't work. And from a safety and certification point of view, also there are some big issues, because at some point you don't know and you can't predict what will happen. And so this is something that from regulation is a big challenge from deep learning. But for sure, there are a lot of things that works 10 times better. So yes, it's a big player.
Sorry, how much for the robot?
Which one? This one, the other. So we have robots that could start from 20,000K. So yes, it's just the mobile base. Yes, this one, the full equipped, for example, with the 5-finger hand and everything, is around 60,000 euro. And the last one, the big one, the Pirene Talos that I've shown you, is less than 1 million euro. It's 900,000 euro. Imagine that the comparative of this robot are Atlas, Valkyrie from NASA, and yes, nothing more. That is more than 2 million. So yeah, we are quite cheap.
Hello. These service robots are a lot about mobility, and they help us. On the other hand, there is a lot of many big players are going into autonomous driving. Is there any collaborative effort right now with service robots on the one hand and autonomous driving, so making people more mobile on the other hand? Are there any efforts in that direction to work together with these big players in the driving field?
Yes. There are different, yes, from, let me say, from a marketing point of view, people and company usually don't like to collaborate too much when are competitor. But from technological point of view, usually people collaborate a lot. So from algorithms point of view and the researcher usually collaborate a lot. And we have a lot of researchers. Imagine that at the moment we are 90% of engineers in the company. We are just 35, we are not 90. But we have a lot of collaboration with big engineers and a big researcher from navigation point of view. And so from technological point of view, usually the researchers are very open-minded and they collaborate. And for sure, then there's patents and other stuff that you have to take into account, so you can't use whatever. But from a research point of view, there's a big community that are collaborate together.
So, Francesco, first of all, thanks a lot. Grazie mille for this wonderful work and your energy in making this dream come through. Just a quick question. So, in developing something like this, you have a lot of issue in mathematics, control theory, etc. Safety.
Correct.
What about security? I mean, how can you make sure that these robots are not hijacked or I mean, used to do something different from what you are planning to do? This is another issue which is very important when you talk to the public. So I wonder what you think about this.
So this is my point of view, but we live in a world that we want to be sure that security has to be there all the time, but we are to be also aware that everything could be hacked. So this is something that could happen. What we are trying to use is we have experts in embedded system engineers that are trying to make the most appropriate, because it's always a trade-off. You could use a very big complicated software in order to encrypt whatever, everything's in, but probably it's overkill, the application. What we are doing is use the most common, let me say, the way to make the security and apply some other algorithms in order to make it not too easy to hack. So this is the way to make the encrypted way, and all, for example, the VPN that we have are encrypted. We use the key public, way. So it's a little bit more complicated. Then, if you are an expert on that, you know that this could be overpassed, for sure. But then it's a little bit more different, and we have already some procedure in order to be aware that something like that could happen and stop this kind of procedure. So when there's someone that knows a lot about it, the only way that you can do is just to take it out from the net and make it as well. For this reason, our robots have all the computational cost inside the robots. So our platform are with the i7. You have seen also the hardware. I put some specification about the hardware in order that could be also works without any connection. So if the robot can detect some intrusion, can disconnect itself and go by his own.
So thanks Francesco. We have to go now, and we have to run because the other talk starts soon. Thank you very much.
Thank you.